Students, today we start the second chapter in Maths 1, Quadratic Equation. First, we have to recall in last year we see the polynomials, we learned polynomials, the types of polynomials by degrees, the polynomials in one variable. Here the first polynomial is 5x plus 1. Here the degree is 1, that means the highest power of the variable or highest index of the variable. Here x is given, that means here the index is 1. Therefore 5x plus 1, the degree is 1, that polynomial is called the linear polynomial. In the second example, x square plus 2x plus 3, in this polynomial the highest index of variable is 2, therefore degree is 2, that is called the quadratic polynomial. If the degree is 3, then it is called the cubic polynomial. We learned that in 9th. Now we have to focus on the quadratic polynomial, that is the second. Let the second example is x square plus 2x plus 3 is the quadratic polynomial. If we write is equal to 0, then it is called the quadratic equation. That means if there is a equal sign, it gets the equation. That means if we write only x square plus 2x plus 3, this is the quadratic polynomial, and is equal to 0, it's get the quadratic equation. Now we saw the general form or standard form of the quadratic equation. This is the quadratic polynomial. This is the quadratic equation. Now the general form or standard form of quadratic equation. Let in general ax square plus bx plus c is equal to 0. It is called the general form of this quadratic equation, where x is the variable and a, b and c are real numbers. Real numbers where a is not equal to 0. If a is equal to 0, that's get the first term is 0, hence the equations became px plus c. That is not a quadratic equations. Therefore a is not equal to 0, where ax square plus bx plus c is equal to 0 is called the standard form or general form of the quadratic equation. Now we see some examples on this. The first type of example is their first type of the questions asked on this topic: which of the following are the quadratic equations? First, we get 11 is equal to minus 4x square minus x cube. If we take this to the another side, we get x cube plus 4x square plus 11 is equal to 0. Here the highest power is 3, that means the degree is 3, that means this is not a quadratic equation. Here degree is 3, that means it is not a quadratic equation. Now second type of question. Minus 3 upon 4 y square is equal to 2y plus 7. Take this to the another side. Minus 3 upon 4 y square minus 2y minus 7 is equal to 0. Here the degree is 2. Here the degree is 2. Hence it is a quadratic equation. Let we get another example. 3 upon y minus 4 is equal to y. This is not a form of quadratic equation, but here the denominator get y. We doesn't have the denominator, the variable, that means we have to multiply the equation by y. We get the equation 3 upon y into y minus 4 into y is equal to y into y. By multiplying equation by y, hence y get cancelled, therefore 3 minus 4y is equal to y square. Now this is a equation. Take this to the another side. We get y square plus 4y minus 3 is equal to 0. This is here the degree is 2. That means it is a quadratic equation. It is a quadratic equation. That means we have to solve these given equations, and if the degree is 2, then it is a quadratic equation. If degree is not 2, then it is not a quadratic equation. Another type of the questions are asked in this topic is second type of the equation. Write example, write the following equation in general form of quadratic equation and hence write the values of a, b and c. Take an example. 3y square is equal to 10y plus 7. Now take 10y and 7 to the another side. We get 3y square minus 10y minus 7 is equal to 0. This is in the form of ax square plus bx plus c. Comparing with ax square plus bx plus c is equal to 0, we get a is equal to 3. Here the variable is y. B is equal to minus 10 and C is equal to minus 7. Similarly, we get another example. P into bracket P minus 6 is equal to 0. Solve this first. P into P, we get P square minus 6P is equal to 0. Here the third term is not given. We write that P square minus 6P plus 0 is equal to 0. That means there are we get three terms. Comparing this, with ax square plus bx plus c is equal to 0. Here the variable is p, hence a is equal to 1, b is equal to minus 6 and c is equal to 0. Now we see the roots of the quadratic equations. The definition of the roots of the quadratic equation: the values of the variable which satisfy the given quadratic equation are called the roots of the quadratic equations. I repeat once again. The values of the variable which satisfy the given quadratic equation are called the roots of quadratic equation. We get one example. Let 6x square minus x minus 2 is equal to 0. This is the quadratic equation, and we get the values are x is equal to minus 1 upon 2 and x is equal to 5. Another value is 5. First we take x is equal to minus half, putting x is equal to minus half in the equation. This is the left hand side and this is the right hand side. Right hand side is equal to 0. Therefore left hand side is equal to 6x square minus x minus 2. Substitute this value. X is equal to minus 1 upon 2 is in the left hand side. Therefore 6 into bracket minus half bracket square minus 1 upon 2 minus 2, which gets 6 into 1 upon 4. The square of minus half is positive. The square of 1 is 1 and the square of 2 is 4. Minus minus get plus 1 upon 2 minus 2. Here we have to simplify. 2 2s are 4 and 2 3s are 6. That means 3 upon 2 plus 1 upon 2 minus 2. The sum of these, the denominator is same. That means we get the sum of the numerator upon 2 minus 2, which is 4 upon 2 minus 2. 4 upon 2 is 2 minus 2 is equal to 0. Hence, it is a right hand side. That means left hand side and right hand side are equal. Hence, x is equal to minus 1 upon 2 is root of the equation. Is the root of equation. Because of this value is satisfied that equation. Now we putting the value x is equal to 5. We get left hand side is equal to 6x square minus x minus 2. So put the value of x is 5. That means 6 into bracket 5 bracket square minus 5 minus 2. 6 into the square of 5 is 25. 6 into 25 minus 5 minus 2. And 6 into 25 is 150 minus 7, which get 143. Here the right hand side is 0, but we get the left hand side is 143. That means it is not equal to right hand side. Hence this is not satisfy the equation. Therefore x is equal to 5 is not root of this quadratic equation. This is not a root of this given quadratic equation. We get some examples on this. The example is this. Determine whether the values given against each of the following quadratic equations are roots of the quadratic equations. In our practice set, we get this example. 2m square minus 5m is equal to 0. The value of m are given 2 and 5/2. First we take the value m is equal to 2. Put m is equal to 2. We get left hand side is equal to 2m square minus 5m. This is the left hand side. So substitute this value in the equation. We get 2 into bracket 2 bracket square minus 5 into bracket 2. The square of 2 is 4. That means 2 into 4 minus 5 into 2 is 10. Which get 8 minus 10. That is minus 2. Which is not equal to right hand side. And hence m is equal to 2 is not root of the given quadratic equation. Now we put m is equal to 5/2. The left hand side get 2m square minus 5m. Substitute this value at here. 2 into bracket 5/2 bracket square minus 5 into bracket 5/2. Hence we get 2 into the square of 5 is 25 upon the square of 4 is 2 is 4 minus 5 into 5 25/2. We solve this. 1 to 2 to the 4. We get 25/2 minus 25/2. That means 25/2 minus 25/2, which get 0. And that means which is equal to right hand side. And hence m is equal to 5/2 is the solution, is the root of the given quadratic equation. One another type of the equation question is asked on this topic is the next example is if one root of the quadratic equation x square minus 7x plus k is equal to 0 is 4, then find the value of k. That is one root is given which is 4. Therefore x is equal to 4 is given, that satisfies this equation. The one root of the quadratic equation x square minus 7x plus k is equal to 0 is 4. The root is given 4. That means x is equal to 4 is the root of the quadratic equation, is the root of this quadratic equation. That means it satisfies the equation. Okay, and we have to substitute this value in the equation. We get the value of k. X square minus 7x plus k is equal to 0. We put x is equal to 4 in the equation. We get 4 bracket square minus 7 into 4 plus k is equal to 0. The square of 4 is 16 minus 28 plus k is equal to 0. We subtract 28 from 16, we get minus 12 plus k is equal to 0. Take 12 to the another side, hence we get k is equal to 12. That is our final answer. K is equal to 12, which is the value of k. Now, so we solve the examples in practice set 2.1, and then in next time we see the methods of solving quadratic equations in another video.